Hello everyone. Now in this video we will study some numericals on most economical trapezoidal section, and we will move further for the most economical circular channel section. As I have already explained in previous videos what is mean by most economical channel section. The most economical channel section is the section which is having low construction cost. Okay, now in previous videos we have studied the most economical rectangular channel, also most economical trapezoidal channel section. Okay, now we will move further for the numericals for trapezoidal channel section. Okay, here in this you can see that there are three conditions for the economical trapezoidal section. First is half of the top width should be equal to the one of the side slope, that is b plus 2nd by 2 should equal to d square root of n square plus 1. D square root n square plus 1 is nothing but your one of the side slope. Okay, sloping side. This side is your sloping side, and this you can see here that this is the top width of the section. Okay, so half of this top width should be equal to one of this sloping side. This is the first condition for the trapezoidal section. Second is hydraulic radius or hydraulic mean depth should be equal to the half of the depth of flow. Okay, this d is nothing but your depth of flow. So whenever you are calculating the hydraulic radius or hydraulic mean depth, that mean depth or that radius should be equal to the half of your depth of flow. Okay, and the third condition is when we are going to draw a semicircle along this flow or along this trapezoidal channel, then that semicircle should touch all the three sides of this section, trapezoidal section. Okay, that is a semicircle drawn from O with a radius equal to the depth of flow will touch the three sides of the channel. These are the three conditions for your most economical trapezoidal channel section. Okay, so we'll move further for the numericals. First is a trapezoidal channel has side slopes of one horizontal to two vertical, and the slope of bed is 1 in 1500. The area of the section is 40 meters square. Now find the dimensions of the section if it is most economical. Determine the discharge of the most economical section if C equals to 50. Now here in this numerical you can see that the section is your trapezoidal section. Okay, and we have to find the dimensions for most economical trapezoidal section. They have mentioned here the find the dimensions of the section if it is most economical. Okay, now they have given the side slopes. Side slope is one horizontal to two vertical. Now I have already explained that there will be two slopes. First will be your bed slope and second will be your side slope. Okay, here in this you have to take bed slope also and side slope also. Okay, because they have given both the slopes. Side slope is one horizontal to 2 vertical. Okay, and the slope of bed is 1 in 1500. That means your n is 1 by 2 and your bed slope, that is I is 1 in 1500. Okay, I will be useful for the calculation of discharge, that is discharge using your Chase's constant. The formula for discharge by using Chase's constant is Q equals to AC root mi, that I is nothing but your bed slope. And in the conditions of trapezoidal section, here you can see the letter N. Okay, that N is nothing but your side slope. Okay, I'll highlight this. Okay, sorry, no, the N is nothing but your side slope and I is nothing but your bed slope. Okay, D is your depth, bed width is B, and here you can simply take this half of D is your this side, remaining side. Okay, because the side slope they have given as 1 by 2, and the Chase's constant is 50, that is C equals to 50. Now by using the conditions for most economical channel section, we can find out the dimensions. Okay, and we have to find out the discharge. So for finding discharge, firstly we have to find out the area. Okay, so that area can be find out by using your most economical conditions also, and by using the area of trapezoid also. Okay, and the hydraulic radius or hydraulic mean depth, that is M, that can be calculated by using your condition for most economical trapezoidal section. Here the first condition is used. The condition is B plus 2ND by 2 equals to D under root N square plus 1, that is half of the top width should be equal to one of the sloping side. Okay, now here in this equation, by using this equation, we can convert your B in terms of D or D in terms of B. Okay, either you have to convert this B in terms of D or this D in terms of B. Here they have converted your B in terms of D, bed width in terms of depth of flow. Okay, N is the known quantity, that is side slope. Substitute in it, you can get the B equals to 1.236 D. Okay, this is the value of bed width in terms of depth of flow. Okay, now the area of trapezoidal section, that is A, I have already explained this in the theory part of this most economical trapezoidal section. Once again they have uh, shown here the formula for it. Here BD plus ND square, or simply you can take down the D outside and write as a B plus ND in bracket D. Okay, so substitute, instead of B substitute 1.236, you can get the area in terms of D. Okay, but the value of A is already given as 40 meters square. Okay, area is given as your 40 meter square. So in LHS you can write 40 equals to 1.736 D square. So by using this equation you can find out the value of D, and the value of D can be substituted in this equation of B, and the dimension for B or the measure for B can be calculated. Here I will show you here. The D is 4.80, and by substituting this value of D in above equation, you can get the value of B equals to 5.933 meters. Okay, D is 4.80 and the bed width is B equals to 5.933. Now the discharge for the most economical channel section or discharge for any open channel flow can be calculated by using Chase's formula. Okay, now Chase's formula is Q equals to discharge equals to AC root MI. Now this M can be calculated by using one of the condition for most economical trapezoidal section, that is hydraulic mean depth or a hydraulic radius will be equals to half of the depth of flow, that is d by 2. Now the value of d is 4.8, so your hydraulic mean depth will be 2.4 meters. Okay, and substitute this area and the hydraulic mean depth in the equation of discharge. We'll get the value of discharge as 80 meter cube per second. Okay, as the all quantities are in meters, so the discharge will be in meter cube per second. Okay, this is the very first example of your most economical trapezoidal section. We'll move further for second example. Okay, this this is the very frequently asked question for your final paper. A trapezoidal channel has side slopes 1 to 1. They have given as a side slopes, that means n is 1 to 1, one horizontal to one vertical. It is required to discharge 13.75 meter cube per second of water with a bed gradient of 1 in 1000. If unlined, the value of chassis C equals to 44, and if lined with concrete, its value is 60. Okay, they have given two conditions. First condition for that channel is the line channel. Okay, if we are going to line that channel with concrete, then the value of chassis constant is 60. Okay, and if it remains unlined, that is if you are not going to line it with concrete or any other material, then the value of chassis constant is 44. Okay, now the cost per meter cube of excavation is 4 times the cost per meter square of lining. Okay, cost per meter cube of excavation is 4 times the cost per meter square of lining. Now the channel is to be the most efficient one. Find whether the line canal or the unlined canal will be cheaper. What will be the dimensions of that economical canal? Okay, now they have given two conditions. First is lined canal and second is your unlined canal, and also they given that the cost of the excavation is 4 times the cost of lining. Okay, now excavation will be in volume and lining will be in your area. Okay, because excavation we are going to excavate something in 3 dimensions. As it is a open channel flow, we are going to remain that upper surface open, so this excavation will be in volume. We are getting the soil in volume. Okay, and the lining will be in square meter. So the cost per meter cube of excavation is 4 times the cost per meter square of lining. Now first they have given side slope n is 1 to 1. Discharge they have given as 13.75 meter cube per second. And bed gradient is also given, that is bed slope is also given as 1 in 1000, that is I equals to 1 in 1000. For line canal C is 44, and for unlined canal C is 44, and for line canal C is 60. Now this condition, which is the cost condition, this can be written in the terms of x. Okay, they have given the cost per meter cube of excavation is 4 times the cost per meter square of lining. So we can assume that the cost of per meter square of lining adds x. Okay, cost per meter square of lining adds x. So the cost of this excavation will becomes 4 times of x. Okay, cost per meter cube of excavation becomes 4 times of x. So here they have written as the cost per meter cube of excavation equals to 4x. Okay, now they have also mentioned that the channel is to be most efficient one. Okay, the channel is to be most efficient one. So for the efficient channel or economical channel, we have already three conditions. Okay, in that three conditions we can use two conditions for this problem. Okay, first is your hydraulic mean depth m will be equals to half of depth, that is m equals to d by 2. Okay, depth of channel, and b is your width of channel. Now also the second condition is half of top width equals to length of a sloping side, one of the length of the sloping side. So the second condition also they have written here as b plus 2nd by 2 should be equal to d square root of n square plus 1. Okay, now here n is known quantity, so this b again, this the value of b can be obtained in terms of depth of flow. Okay, here the value of b can be obtained by depth of flow as 0.828 d. Okay, now substitute this in the equation of area, that is BD plus ND square. You will get 1.828 D square. Okay, area will be equal to 1.828 D square. Now why I have done all this, or why they have done all this? Because B and D value is unknown. Okay, now by using the conditions you can obtain m and area in terms of d. Okay, you can obtain this m and a in terms of d. C value they have given, so for calculating discharge all the values can be obtained in terms of depth. Okay, because discharge they have given for the both types of channel, that is 13.74. Okay, now for first condition, that is for unlined channel, the unlined channel value of Chase's constant C is 44. So as I have already explained right now, that is discharge can be calculated in terms of D. So discharge value is given, we can find out the D value by using this discharge equation. Okay, Q equals to AC root MI. This is the continuity equation. Q equals to AV is the continuity equation, and Q equals to AC root MI is your Chase's equation for discharge. So substitute the area in terms of D here, hydraulic mean depth in terms of D, and the discharge value Q is given as 13.75. Okay, by calculating this mathematically you can get the value of D as 2.256. Okay, 2.256. And here you can see that for finding the value of b, you can substitute this d in b equals to 0.828 d. We will get the value of bed width also, which is equal to 1.868. Okay, now we have to find out which is the most economical one. Okay, and for that they have given as the cost. Okay, so here we have to consider your cost of excavation. Now as this is your online channel, we can only consider the cost of excavation here. Okay, so cost of excavation per running meter length of a online channel equals to the volume of channel, that is total volume of your channel, equal into cost per meter cube of your excavation. Okay, because cost per meter cube of excavation is given to us, which is 4 times the x. Okay, x is nothing but your cost of lining. Now here we are not going to consider your whole canal or whole channel. Okay, we are going to consider only 1 meter length. That is unit length. So here we are going to consider volume of channel as your area of channel into third dimension is your 1 meter length. Okay, area of channel we have calculated into 1 meter length will be your volume for that 1 meter canal length, and the cost for that per meter cube of excavation is already given. By using these quantities you will get the cost of excavation as 37.215 times x. Okay, that is x we have considered as the cost of lining per meter square of lining. So 37.215 times the cost is for the excavation. Okay, this is for the unlined channel. Now we'll see what happened for the line canal. Now for the line canal, the your method is same, only we have to change the dimensions because value of chassis constant is different here. The value of c is your 60. Now discharge by using this equation will be AC root mi, and the only the changed value is c here, so d and b will be changing. So d here will get d, the d value is 1.992 meters and the width is 1.649 meters. Okay, here c changed, so the depth and width is also changing. Now for the calculation of cost, here as this is the line canal, we have to consider the cost of excavation and the cost of lining also. Okay, cost of excavation is also considering and the cost of lining should also consider. So now cost of excavation will be same. We have to calculate the cost of excavation as before, volume of channel into cost per meter cube of excavation. Okay, here volume will be changing because d and b value is changed, so the cost of excavation will be 29.01 times your x. Okay, here for line canal cost of excavation you have the value of cost of excavation as 29.01 times x. As we can see here that for unlined canal the cost of excavation is somehow high. Okay, 37 times x value is comes out to be, and here the cost of excavation comes out to be 29.01 times x. Okay, but here we have to add the cost of lining also. The excavation is done, now we have to do the lining for that canal. Okay, so lining of canal can be calculated by using your area, because cost per meter square of lining is given. So the area of lining into cost per meter square of lining we can take. Now here also, as we have done in the volume, we take the 1 meter length for calculating the volume. So for area also we have to take the 1 meter length. Now area can be calculated by using perimeter into 1, that is 1 meter length, into the cost per meter square of lining. It is considered as x. Okay, so calculate this and substitute the values of b and d in the equation. You will get 7.283 times the x. Okay, so total cost for the line channel will be the addition of your cost of excavation and the cost of lining. Okay, so add 29.01 and 7.283, you will get 36.293 x as the total cost of a line channel. Okay, by seeing both the values or both the cost, for unlined channel it is 37.21 and for line channel it is 36.29. Okay, so by seeing this we can easily or directly say that a line channel is the most economical channel. Okay, line channel is the economical channel than unlined channel. So the dimension for economical channel will be same as that of for the line channel, that is b equals to 1.649 and d equals to 1.992 meters. Okay, this is all about the numericals for your most economical trapezoidal section. The all the other examples will be same for most economical trapezoidal section. We will move further for the next theory part of your most economical trapezoidal section, that is the side slope. Okay, here you can see that the best side slope for most economical trapezoidal section. Okay, this is the theory question. You may ask this theory question in your final exam. So this is also very simple, only uh, you have to remember the formulas for area, for perimeter. So the area of trapezoidal section will be A equals to B plus ND into D, that is BD plus ND square, where B is nothing but your trapezoidal channel, D is nothing but depth of flow, and N is nothing but your slope of the side of channel. Okay, I hope you have remembered the area of trapezoidal section, which is BD plus ND square. Now we can convert this area equation and we can find out this value of width, that is B, in terms of A and D. Okay, so find the value of B, simply rearrange this. You will get the value of B as A by D minus ND. A by D minus ND. Okay, the value of B is known. Now the weighted perimeter for the channel will be, the section of trapezoid and the three sides of that trapezoidal section is to be considered. two sloping sides we have to consider, and one bed width we have to consider for the weighted perimeter. Okay, b is your bed width, and d square root of n square plus 1 is the one of the sloping side. So multiply this in 2, we'll get two sloping sides. So this is your perimeter for that channel, weighted perimeter for that channel. Now here we can see that the b is given. Okay, b is given, so we can substitute this equation instead of b here. You will get the perimeter as a by d minus nd plus 2d square root of n square plus 1. Why I have given here perimeter? Because here the title explains that side slope is for most economical trapezoidal section. Okay, this side slope is for most economical trapezoidal section, and as we know that for most economical section, then any section, most economical section, the first condition is discharge from that section will be maximum, and the second will be the weighted perimeter of that channel section should be minimum. Okay, so here I have find out the weighted perimeter of that trapezoidal section. Now as I have know that this is the most economical trapezoidal section. Okay, so as this is the most economical trapezoidal section, this weighted perimeter should be minimum. Okay, should be minimum, and the derivative of this perimeter with respect to side slope will be equals to or must equal to 0. Okay, because this whole section is already a economical section. Okay, now as we have this condition, we can differentiate this weighted perimeter with respect to your n. Okay, so differentiate it. dp by dn should be equals to 0. Now only the thing is that you have to remember all the derivatives, that is the what is the derivative of 1 by x, what is the derivative of x, and what is the derivative of root x also. So calculate all the derivatives of this equation. You will get the value as 2n equals to square root of n square plus 1. Now here you can see that here there is a square root. Okay, so we have to cancel this square root. So for cancelling this square root, we have to square on both sides. Okay, square, we have to square the 2n, and we have to square this whole root also. So we'll get n value as square root of 1 by 3. That is, square root of 1 is simply 1. So n will be equals to 1 square root of 3. Okay, n will be equals to 1 square root of 3. Now this n is nothing but your side slope. Okay, n is nothing but your side slope. That is, the if the sloping side makes an angle of theta with the horizontal, then we have, suppose this angle is theta. Okay, theta means this sloping side makes an angle of theta with this x axis, that is horizontal. Okay, and by using this triangle, we can find out the tan theta as 1 by n, that is opposite side upon your adjacent side. Opposite side is nothing but your 1, and adjacent side is your n. N is nothing but your slope. Right now we have calculated that slope as 1 by root 3. So simply rearrange this, you will get tan theta equals to root of 3. Okay, so tan theta equals to root of 3. So for finding out theta value, we have to inverse this. That means theta should be equals to tan inverse of root 3. Okay, tan inverse of root 3 is 60 degrees. So the theta value is 60 degrees. For most economical trapezoidal section, for by using this theta value, we can say that for most economical trapezoidal section, the side slope should be 60 degrees to the horizontal. Okay, that means the sloping side should make or must make 60 degrees angle to the horizontal. Okay, and also we can say that the value of slope of that side should be 1 by root 3. Okay, 1 by root 3. That means n should be equals to 1 by root 3 and the theta should be equals to 60 degrees. Okay, now further we will move. We have already the conditions for the most economical trapezoidal section, as the half of top width should be equals to the length of one of the side slope. Okay, and right now we have calculated the value of n for the best side slope. Okay, n is 1 by root 3. Okay, by using this equation, that is b plus 2nd by 2 equals to d square root of n square plus 1. Substitute n as 1 by root 3 in this equation. You will get the value of b as 2d divided by root of 3. 2d divided by root of 3. That is, your bed width should be equals to 2d divided by root of 3. Now we can find out the weighted perimeter for the same. Weighted perimeter should be equals to this formula. You have to by heart this formula, that is p equals to b plus 2d square root of n square plus 1. Okay, here n value is 1 by root 3, as this is the most economical channel section and the side slope is also the best side slope. Okay, so the value of b and the value of n is already calculated. For the best section, we have to simply substitute that b value and the n value in the space of b and n. Okay, by simply doing the mathematical calculations, you will get the value of weighted perimeter as 3 times the b. Okay, 3 times the bed width. That means the weighted perimeter for the best side slope and best section should be equals to 3 times the bed width for the channel. Okay, by doing this all theory parts, you can simply say that for the slope of 60 degrees, length of sloping side is equal to the width of trapezoidal section. Okay, that means perimeter, for perimeter we are going to take 3 times one dimension only. Okay, and that one dimension is your bed width. So by using this equation, we can put a statement that length of sloping side is equals to the width of your trapezoidal section. Okay, now we'll move further for the numerical on the same part. A power canal of trapezoidal section has to be excavated through hard clay at the least cost. Okay, at the least cost. Now determine the dimensions of channel given. Discharge equal to 14 meter cube per second. Bed slope is 1 in 2500 and the Manning's N is 0.020. Okay, here in this example they have given that the channel is to be excavated in hard clay. Okay, at least cost. At least cost means this channel is the most economical one. Now we have to determine the dimensions of this channel. Discharge is given as 1414 meter cube per second and the bed slope is 1 is to 2500 and the Manning's N is 0.020. Your bed slope is nothing but your I is 1 divided by 2500. Now for the excavation of canal at the least cost, as I have already explained, at least cost means this channel should be the economical one. Okay, so we can use the conditions for most economical trapezoidal channel section. Okay, and also we can now use the conditions for best side slope also. As you can see in this example that they did not give side slope any side slope. They only give the bed slope value. Okay, and they mention that this channel is to be excavated in the least cost. Okay, so we can assume that this channel section is the is to be most economical one. Okay, so the theta value will be 60 degrees and the side slopes will be, that is n will be equals to 1 upon root 3. Okay, as I have explained this earlier, and b equals to your width of channel and d equals to depth of flow. Okay, so we can use the conditions for b also, for n also, and for the weighted perimeter also. Okay, simply we have to find out the dimensions for this channel. Use the first condition for most economical trapezoidal section, that is half of the top width should be equal to length of one of the sloping side. Okay, half of top width means b plus 2nd divided by 2 should be equals to d square root of n square plus 1. Okay, here we can use n value as 1 by root 3. Okay, as they have explained as that this section is the most economical section and they did not give any value of your side slope. So for most economical section, if the side slope is not given, we can use the side slope n equals to 1 by root 3 and the angle theta equals to 60 degrees. Okay, also we can use the condition for b, that is bed width, that bed width equals to 2d divided by root 3 and the weighted perimeter should be equals to 3 times the b, that is your bed width. Okay, so substitute in instead of n, substitute 1 by root 3 here and simply do the rearranging. You will get b equals to 2d square root of 3. if you are going to skip this step, you can skip, because this 2d by root 3 equals to b is one of the condition for most economical side slope or most economical trapezoidal section. Okay, you can skip this step also, and you can directly write down as b equals to 2d by root 3. But before this you have to explain it all, as this is the most economical section. Okay, now the area of trapezoidal section. The value of b is known to us, that is 2d by root 3, and the area of trapezoidal section can be calculated by using BD plus ND square. Okay, BD plus ND square. So substitute 2D by root 3 instead of B and simply rearrange this and do the mathematical calculations. You will get the value of area of this trapezoidal section as root 3 D square. Okay, what is the area of our trapezoidal section? Area comes out to be root 3 d square. Okay, now the third condition. Third condition for the trapezoidal section is the condition for hydraulic mean depth. Okay, that is m. Hydraulic radius will be equals to half of your depth. Okay, so m will be equals to d by 2. Now before proceeding, you can here see that we have b in terms of d, we have area in terms of d, and also we have hydraulic mean depth, that is m, in terms of d. Okay, the value of I is already given. Value of I is already given as, in the problem, I is given as 1 divided by 2500. Okay, so all the values in terms of d we have calculated. Okay, but here the Chase's constant is not given. Okay, Chase's constant is not given. Instead of Chase's constant, they have given Manning's n. Okay, so you have to remember what is the formula for finding out the Chase's constant by using Manning's formula. Okay, so here by using Manning's constant, C equals to 1 by n m raised to 1 by 6. Okay, you can simply take this formula in space of C here. Find out the value of discharge. Q equals to AC root mi. A is root 3 d square. C is nothing but, by using Manning's constant, 1 by n m raised to 1 by 6. So substitute this value instead of C, 1 divided by n m raised to 1 by 6, and root of mi. So root of m into 1 by 2500. Now this m is written as it is. Okay, so why this m is written as it is? Because in outside of square bracket there is also m. Okay, we can add the power of both the m. So add the powers of m's, you will get the value as 1.732 d square into m raised to 2 by 3. Okay, now here you can see that the unknowns are only d. Okay, in uh, in space of m we can write d by 2. Okay, in the terms of m, the m can be written in terms of d. Okay, so substitute d by 2 instead of m. You will get q equals to 1.732 d square into d by 2 raised to 2 by 3. Okay, now q is given as 14, so substitute it. Only now the unknown is your depth. Okay, that is d. So by calculating this all, you will get the value of d equals to 2.605 meters. Okay, only the thing is that here you have to remember how to add the powers of the letters, or how to subtract this. Okay, so this is the very basic mathematics. I am not going to explain this. So d equals to 2.605 meters. Now by using the equation of most economical channel section, trapezoidal channel section, b is nothing but your 2d by root 3. Okay, b is nothing but 2d by root 3. So substitute the value of depth in this equation, that is 2.605 meters. You will get the value of b as 3.0008 meters. Okay, 3.0008 meters is the bed width of your trapezoidal section, and the depth is 2.605. If they ask to find out the perimeter, now how you are going to find out that perimeter? Simple, by using the formula for perimeter of the best side slope. Okay, you can use this formula, that is p equals to 3 times b. By using this formula you can find out here perimeter also. Okay, this is all about the most economical trapezoidal section. Now we will move further for the most economical circular section in next video. In this video we have learnt the numericals for most economical trapezoidal section, and also the theory part for best side slope of the most economical trapezoidal section. Remember the thing that there are two slopes, one is n and one is I. I is nothing but your bed slope and n is nothing but your side slope. Okay, I is nothing but the bed slope and n is nothing but your side slope. So in the and also you have to remember the differentiation also and the simple mathematical calculations. So in a whole module, the two slopes you have to remember, first is I and second is n. Okay, so we will move further for the most economical circular section in next video. Up to this we have covered most economical rectangular section and most economical trapezoidal section along with the numericals for both the section. Okay, thank you.